Unit 2, Lesson 7 homework with me, Miss Billman. This one is kind of long, so just sit back, relax, and let's work together. So we're going to find the perimeter and area. All of these are a complex shape or a complex figure. They tend to have, more than two shapes squished together, or two or more. That happens. So quick reminder, perimeter is everything around. If I were to draw a fence, that'd be like the perimeter. The grass on the inside would be the area. So this one's pretty straightforward. To find the perimeter, I'm going to add all of those numbers together. Now, why? Because the 3 that's on the left-hand side, that's pretty much the height right there. And I go all the way around, and it's telling me the lengths of everything. So I add it together. 3 plus 2 is 5. And I get another 5, and 2 plus 6 is 8. I add it together. 5 plus 5 plus 8 is 18. So I have a perimeter of 18 yards. Now, when I do area, I need to tend to precision. Why? Because I need to decide how do I want to split these up. Now, I have made a square, a rectangle, and a trapezoid. It's one of those weird looking trapezoids, but it still works. I did this by looking at where there was a bend or where I felt there was an easy line that could be made to make a figure. So if we look at the right, it's 2 by 2. So I multiply that, I get an area of by 4. Now if we look at the left, it has a height of 3 and a width of 2. 3 multiplied by 2 is 6. And this is where things get tricky. I need to remember the area, to find the area of a trapezoid, I have a formula. And it's base 1 plus base 2 divided by 2 and multiplied by the height. Now, that 3 on top, it really doesn't mean too much to me. That's just a side length. But now I have to look and think, what is the height? So I have a height of 2 on top and a height of 2 on the other side. And I know the complete length is 6. So it must be 2 plus 2 plus 2. So the height is 2. The base is the same length that matches for the base 1. The same thing that matches for the 2. And the same thing that matches for the bottom, which is 3. So 2 plus 3 is equal to 5. 5 divided by 2 multiplied by 2. So I'm going to leave it in a fraction, 5 seconds or 5 halves. Multiplied by 2 over 1 is 10 over 2, which is equal to 5. So I add those numbers up. 6 plus 5 plus 4. And I get a total of 15 yards squared. Now that is truly a complex figure. Now let's look at this one. We have a length of 9 and a height of 5. Now if I have that little bitty length, it has to match the bottom because then it'd be congruent. So I have to have 4 plus 5. To find that empty space that's vertical, it must be congruent to that 5 length. So and I have a number of 2, so it'd be 3. So I add all those numbers up together. 5 plus 5 plus 3 plus 4 plus 2 plus 9. And I'm going to turn this into a square and rectangle. So that rectangle is 4 multiplied by 2, which is 8. And that square is 5 multiplied by 5, which is 25. I add those two together, and I get a total of 33. So 33 centimeters squared. To go from a complex shape or a complex figure, to make it most easy, I would split it into shapes that I know and I feel confident about. So I myself would not try and split it up into as many triangles as possible. Maybe I feel better about quadrilaterals and parallelograms. Now this one has a lot of little numbers, and we have to really look and see, where do these numbers match up? So I added up the vertical length. So 2 plus 1 plus 3 for the vertical length, and that would be 6. So the left-hand side is 6. Now, if I wanted to make this a complete square, I could then, figure out, okay, well, if this bottom is 3, to match the 6, there must be a missing length of 3 right there. Right now, I'm adding up all of the tiny little numbers for the perimeter. 12 plus 6 plus 6. And I get number, that's 18 plus 6, which is 24. So I have a perimeter of 24 centimeters. Now my area. This is where I'm going to dive in. That top little nub that is 1 centimeter, I'm going to make it a square. So it's 1 centimeter by 1 centimeter. Now my 6 across the top, now that becomes a 5. Why? Because I took away 1. Now let's look at this bottom quadrilateral. Now I have to think, okay, so that must be 3 because I want it to match it. And 3 plus 3 would equal 6, which is the total length. I can't just make up lengths. And so my bottom quadrilateral is 9 because it's 3 multiplied by 3. And my top is 15 because it's 5 multiplied by 3. I add all of that together and I get an answer that is 9 plus 15 plus 1, which is equal to 25. So 25 centimeters squared. Number 4. We are looking at 2 triangles that have all the same measurements. So this is pretty straightforward to get the perimeter. So 3 plus 4 plus 5. So that's 12. And it happens to be 12 on the other side as well. So it's 24 centimeters. So to find the area, I multiply my base and my height. My base is my 3. My height is my 4. 5 is the side length. I don't need to touch it. So for each, it is 6. And I add that together. And I get 12 centimeters squared. And you'll see I'll go back on the perimeter and take away that squared. You do not need it, Miss Billman. Okay. These ones, we're finding the area of a shaded part. So they gave me some information as far as C, D, E, F. And that has a total of 24, an area of 24 feet squared. Now, when I'm looking at these, I have to know that if the length is 6, my width must be 4 because it's 24 centimeters squared or feet squared. And the only other number that I have, I could do like 24 and 1. I could do 12 and 2, but I have 4. So that 4 is what my 6 will multiply by. Now, when I'm trying to find the area of that tiny little triangle, what I will do, because my base is 4, I just happen to put it on the bottom, I'm going to make that a huge triangle, right? So I'm going to do 6 multiplied by 4 divided by 2 is 12 for a big triangle. Now to get that tiny little triangle, I'm going to do 6 multiplied by 3 divided by 2, which is 18, divided by 2, which is 9. So then I'm going to subtract it. 12 minus 9 is equal to 3. So it has an area of 3 feet. Number 6. Now, this is when I have to look closely at what these lines are. So if they're dashed, that's kind of giving me a hint that I can add those together. So the 8 and the 4, and that's going to get the total height of that triangle. It has it split up into 2 triangles, though. It does 10 for a base, and on the other side, it has a separate base. So to find the total triangle first, and then I will subtract the rest. So 10 multiplied by 12 for the left-hand side. 120 divided by 2 is 60. So I need to keep that number in mind. Now I'm going to subtract that tiny little triangle, which has a base of 10 and a height of 4. Or I could even do a base of 10 and a height of 8. Either way, let's take a look at it. So 60 minus 40. So I know right there, okay, I got a number. It's 40. Now why? Because it's the difference between the two. When I'm finding anything with a shaded area, I might have to start large and work my way down. That's how that is, right? So my tiny little triangle has an area of 20, and that has to mean that my shaded area is 40 because my total was 60. The tiny area was 20, so there's 40 left over. So now for the right-hand side, I have a base of 6 and a height of 12. It's that 8 and the 4. I multiply those together. I get 72. 72 divided by 2 is 36. So the total area is 36 for the big triangle. But now I need to find that tiny little triangle. It has a base of 6 and a height of 4. Divided by 2 is 24 divided by 2, which is 12. Now I'm going to subtract it. 36 minus 12 is 24. So now I add those together. 40 plus 24 is equal to 64 centimeters squared. Paul is making a birdhouse with the measurements shown at the right. What is the area of the back of the birdhouse? So we're really looking at this drawing or model. Now, when I'm doing a back of the birdhouse, I don't have to worry, luckily, about any doors, or maybe there are doors for birds to get out. I don't know. It's been a while since I made a birdhouse. But I'm going to split that into a quadrilateral and a triangle. Now, I know my quadrilateral has a height of 23. I'm going to multiply 23 and 19 to get the area of that quadrilateral. But you notice there's a dashed 33. That dashed 33 is telling me that entire dashed area from the top of the triangle to the bottom of that quadrilateral, it's 33. Now, I don't need to do a base of 19 and a height of 33. That wouldn't be correct. But I do know that if the quadrilateral is 33 and there's a total height of, or quadrilateral is 23 and a total height of 33, it must be 10. So I multiply 19 by 10. I get 190. I divide that by 2. And I do know it'll be about 95. So I add those together. 437 plus 95. 7 plus 5 is 12. Carry the 1. 9 plus 3 is 12. Plus 1 is 13. And I get a total answer of 532 centimeters squared. This one is about walking sign. How much metal will be needed to make 4 of these signs shown at the right? So I'm going to split it into a rectangle and a triangle. So my rectangle, pretty straightforward. It's 30 multiplied by 15. I go through and multiply this. Now remember, there is a middle dashed line that says 30. That means from the top of the triangle to the bottom, it is 30 inches. But my rectangle is 15. So it's actually that the height of that triangle is only 15 inches because it can't be the entire thing. Then we're just turning it into a diamond, and that's not what we're doing. So I multiplied the 30 and 15, and then I'm going to multiply 30 and 15 once more. Now this time I will divide it by 2, and I get 225. Now I can add the 450 plus 225 and get 675, but that's just for 1. Now I multiply it by 4 to get the total, like the question was asking, how much metal will be needed for 4 signs. So I multiply that out. That's 30, carry the 3, 24, 27. So 2,700 inches squared will be needed.